Right, difference of two squares. Let's factorize a difference of two squares. So firstly, what does a difference of two squares means? Well, it means a square minus another square. So that's why we call it a difference, because in maths, a difference is minus. So how do we factorize this? Well, we can factorize it as a plus b times a minus b. Let me show you firstly why, because I don't like giving you things away without proving them. Well, actually, here, the better way would be to just work your way backwards from the right-hand side. So if you do a times a and then a times minus b, that would give you a squared minus ab. And then if you multiply b times a and b times minus b, let's see what we get from that. We get plus ba, which is the same as plus ab. Ba is the same as ab, obviously. And then you have plus b times minus b, which would give you minus. And then b times b just gives you b squared. So notice what happens here. Our favorite thing in the middle happens here, because you have minus ab plus ab. These things kind of cancel each other out, leaving us with simply a squared minus b squared. So this is indeed proven. Happy days. So this formula is actually true. So you can now believe me because you have seen me prove it. So let's try to memorize this formula. It's a handy little formula. We'll always see this in front of us in many different questions in algebra. Basically, a squared minus b squared is a minus b times a plus b. Or same thing, you can swap the two pairs of brackets around and you can remember it as a plus b times a minus b. So keep this in mind. Let's move on to an example. Let's see how we would factorize now 9 minus x squared. Well, firstly, the thought process would be, well, how could we rewrite this as a squared minus b squared? Something squared minus something else squared. Do you see how we can rewrite 9, guys? Yes? 3 squared, right? Because 3 squared gives you 9. You're not going to square the 9 because then you would be changing it. You just want to rewrite it as something close. Oops, sorry. Let me just go back. So basically here, guys, you need to think of the formula, which says this is going to be a plus b times a minus b. Exactly. So you want to rewrite it as 3 plus x times 3 minus x. And that is simply the factorization. If you were to expand the brackets now, you would see that this simplifies down to 9 minus x squared. Let's move on to the second one, because I think the more of these we do, the more it will make sense. 4x squared minus 25. Okay, let's process what I just said. He's thinking out loud here. We want to rewrite this as a squared minus b squared. So we want to rewrite the 4x squared as something and all of that squared. So it must be 2x and all of that squared. Let's do one step before that. Let's just rewrite it so that it's in a convenient form for us. Now we've rewritten the first one as something and all of that squared, because you can see here 2x times itself actually gives you 4x squared. And now let's do the same thing for the next bit, which is the 25. So how can you rewrite the 25 as something squared? 5 squared. Exactly. And now this is in the form we want it in. It's in the form of a squared minus b squared. And remember, this can be rewritten as a plus b times a minus b. So what is our a in this case? It is 2x. What is our b in this case? It is 5. So we can rewrite this in brackets by saying this is going to be 2x plus 5 in the first pair of brackets. And then we need to open a second pair of brackets and put the same thing, but with a different sign, 2x minus 5. And now if you were to expand all the brackets and do all the nitty-gritty work by collecting like terms and stuff, you would actually get 4x squared minus 25. Now let's see, could we get a problem which looks a little bit different? Yes. Now here you will notice most students will try and they'll say, I can't get something squared to give me 2 here, like a whole number. And I can't get something squared to give me 8, right? Yeah, but that wouldn't quite help. We want things squared. So here the trick is that they have tricked you. They want you to notice something here. This 2 and the 8, they have a common factor. So what is the common factor of these two? It's 2. So if we rewrote this as 2 brackets, and then in the brackets put x squared minus 4. Great stuff. Now you can see that indeed the thing inside the brackets, the x squared minus 4, this is in the form a squared minus b squared. Can you see? Because the 4 is actually 2 squared. So now you have x squared minus 2 squared, so you could rewrite this as a plus b times a minus b. So what is our a in this case? X, right? A squared is x squared, so a is x. And then b is 2. B is the 2. So remember, the a is the thing under the square, and the b is the thing under the square. So if you remove the squares, you'll find your a and your b. So in this case, you'll have a plus b, which is x plus 2. That's the first pair of brackets. And the second pair of brackets will be a minus b, which is x minus 2 in this case. So this would be the final factorized form. So you see, in some cases, we need to find the common factor before we actually do the process we did previously. And let's have a look at this one, because this one, I think, perhaps is a bit more confusing. So firstly, let's try to spot what the common factor between this and this number will be, the 3 and the 48. So do we have a common factor here? 3, well spotted. That's it. So let's rewrite this. If we put a 3 outside, what do we need to put inside the brackets?
1x squared.
X squared.
X squared, and then the other one would be
16?
plus.
Okay, what about plus, minus, anything like that?
Plus. Yep. Plus. I think it's minus 3 minus and x minus 16.
Aha, well done. It's excellent. I had a very good idea. I'm going to tell you 2 ways to do this here. Either you will need to keep the minus as it was before and put a plus next, or even better, or I'm going to say here, I prefer the second one, which I used, which is you put a minus 3 outside, because in some cases we want to do that to change all of the signs inside the brackets, all of these signs. So if you choose a minus to put outside here, then it will change this to a plus, and it will change this to a minus, because that's what the minus does. So then you would put inside the brackets x squared minus 16. And now this looks a lot better, because this looks a bit more like a squared minus b squared, which is a thing we are used to factorizing up until now. So let's wrap this up, guys, and let's say, how do you factorize x squared minus 16 inside the brackets? Okay, great. And how would you put that in 2 pairs of brackets?
X minus 4 and x
If we excellent, because we know a squared minus b squared is a plus b times a minus b. And in this case, this is actually equal to x squared minus 4 squared. Well, we know from that we need to put inside these 2 brackets x plus 4 and x minus 4. So that is going to be our final answer here with a minus 3 in front. And the other way would work as well, but it just involves a bit more work. I would say you need to swap these 2 around and rewrite it as 3 brackets 16 minus x squared. And then you would have to factorize it as 3 brackets 4 minus x times 4. Let's say 4 plus x times 4 minus x. I wouldn't recommend this. I'll put it in brackets. I will say better no. So better avoid this method. And this we'll call the method. The method is better. Okay, so try to use this method. When you have x squared minus 11, it might seem like you can't factorize this, but actually, what number squared gives you 11? What number squared gives you 11? Something squared is equal to 11. A decimal. How would you, what kind of notation? Square root. Square root. So basically the square root of 11 squared would give you 11. So if you wanted to, we don't tend to do this in maths usually, but if you wanted to, you could actually think of it as, oh, this is x squared minus the square root of 11 squared. So you could now use the formula and say, okay, this is going to be x plus the square root of 11 in 1 pair of brackets. And then in the second pair of brackets, you'll have x minus the square root of 11. So if we really needed to, for some reason, we could do this. We could use the square root for these whole numbers. And then promise, I'm not going to do This is the last one, I promise, guys. I don't want to talk too much. But this one is slightly more complicated, and it will let you solve the hardest questions from today. So you can think of it as a squared minus b squared. So here, this is your a, this entire pair of brackets, and your b. What is b so that you get b squared is equal to 9? 3, exactly. So you can think of this problem as 3x plus 2 squared, and then you have minus 3 squared. And now you can use the formula which we've seen before, which would say you have to do a plus b times a minus b. Now, in this case, the problem is that a is your entire pair of brackets here, the 3x plus 2. So inside the first pair of brackets, what we will put is all of this. This is our a. Let me say that this is our a, and this is our b. So we put this 3x plus 2, and then we need to put plus b in there. So plus 3. And then in the second pair of brackets, we need to do a minus b. So we'll have the entire thing from 3x plus 2 from the first pair of brackets. So 3x plus 2. And then we put the minus b, which is minus 3. Brilliant. That's pretty much it. But we don't like this so much. We need to do a bit of a simplification. You see this 2 plus 3 and the 2 minus 3. We want to simplify this so that it looks a bit better, a bit more simplified. So what is 2 plus 3? 5. So we have 3x plus 5 in the first pair of brackets. And 3x minus 1, excellent, in the second pair of brackets. And that's pretty much the hardest possible difference of squares one would expect of somebody your age at this stage, if not GCSEs. Yes. Let me just stop the recording here.